Hello, my name is Rodrigo and I work for Spin Engenharia. In this video, I will introduce the Lean Automation process in detail. Lean Automation is a methodology developed by Spin oriented to the parameterization and implementation of a SCADA software for the supervision and control of any process. Since 1992, Spin works with development and integration of SCADA software in electrical applications. This experience got us good results so far and has enabled us to evolve with the development of the work. The result is ActionNet, our newest SCADA, with features that make it possible to implement lean automation, which can be applied in any market similar to the electrical one. The goal of lean automation is to automate an application in less time and with lower costs, higher quality and flexibility. Until now, we must confess that we do not know a similar solution in our market. I will use a real example to present the methodology. The idea is for you to understand at the end of the presentation the real benefits of lean automation. We will automate 3 substations of a wind farm. The substations are similar and consist of a set of similar bay types, also with suitable elements each. Let's identify them by the name TX. These are the diagrams of the 3 substations. Each substation bay type 1 is marked in red. This, for example, is a line bay that collects what's being generated and sends it to the transmitting substation. In this application, there are 32 bays, of which 5 are bay types. This will enable me to reduce by 1/6 the development time and the application deployment. Within each bay type, there is a connection between SCADA software and relays that control the bay types, giving them features and functionalities. That is, the relay controls and allows remote control of elements of the bay type. Now that we have a sense of the elements involved in this project, we will better understand the phases of an automation project. All integration begins with a work statement. This is the moment to understand the elements and the variables of a project. After the information is collected, we can start the construction of the project itself, the parameterization of the application. Thereafter, it's time to make some tests. One takes place in a laboratory environment to check whether the parameterization has occurred as expected. The following is the factory environment test, when we deal with the real panels of the application versus the configured software. And finally, the field test, with everything in place to ensure that there are no errors. To complete the integration, teams need to be trained, documentation relating to the operation and maintenance must be registered, and the service guaranteed. With lean automation, Spin is able to act directly on the phases of setting parameters and tests, which are the most critical of any project. It's important to talk about each of these steps. In the application parameterization, you gain with the definition of bay types that we call templates. ActionNet offers the benefit of building categories. This functionality allows for each system tag the creation of up to 32 associated properties. I can, for example, indicate that a tag is linked directly to alarms or events, or an event is a type that needs to be recognized by the operator in order for him to exit the alarm condition. That means new features specific to each tag. With ActionNet, you can also create and manipulate symbols in a remarkably easy and intuitive way. And to close the parameterization stage, we offer deploy, which is used in design time, automatically generating for each new bay, alarm and event condition tables, condition history file generation, and a list of addresses 1 and 2 of input and output tags. The first address may be, for example, the IP of a relay. Let's see how each feature appears in ActionNet. First, the bay type. Here we have one bay line, one bay transformer, one bay capacitor, and another bay transformer. The categories appear this way as fields to be marked. To create and manipulate symbols, we have a powerful tool. Deploy already is in the extension sections of ActionNet. For a new symbol or template to become part of ActionNet libraries, it must be thoroughly tested. From primitive to complex symbols, status colors, prevented object identification, or objects without communication, in short, all the features that a tag can have must be tested. This ensures that the content of this library will work identically in any situation that requires the bay type registered. This is the basis of our methodology. Setting up a substation becomes a work of a few hours. We are able to mount displays in minutes. Reports are already built with alarm files, events, operation reports, operation logs, tag reports, measures, and trends. It is also possible to spend an additional hour adjusting alarm messages according to the client's culture. Considering the features of SCADA tested, we live for the test in a laboratory environment. To test the parameterization of a relay associated with a bay type, you must copy the relay program for a test relay. If I have 5 bay types, I will test each one of them against the relays parameterized properly. The relay must be configured with its IP. It must be connected to the relay application that was generated, and then we can test all the tags of the first relay. After the successful test, we must save up the program. After the bay type and relay tests, whenever one identical bay must pass through a laboratory test, we simply connect it to the SCADA and cause a tag reading. If the test goes well, all other features are correct. So far, we have tested the functionality of SCADA and its connection to intelligent electronic devices. During factory tests, for each relay of a panel, we need to confirm the address and the program that was loaded into it. We do this by successfully reading a relay tag. We then test the panel terminal that interfaces with the field. In the case of our 3 substations, we would spend only 25% of the time that is spent by a conventional method. For the field test environment, we need to monitor the functioning of SCADA in its final environment. Considering the path we have taken so far, all we need to do is test a tag on each panel. If the test runs, we have the guarantee that the address is correct, as well as the program and the connection between SCADA and relay. Then we should command each bay of all devices to test connections. A process that usually lasts 1 day for each bay shall last an eighth of the time. Well, we've shared a lot of content here. To conclude, it's good to highlight the advantages of lean automation. With this methodology, your integration team needs not to be so experienced. The work is easier and more intuitive. The fact that libraries are pre-tested increases the quality level of the project. The reduction of test time is striking, reaching an eighth of the normal time. With less working time, you spend less on logistics and testing. The more libraries are, the easier it is to generate new libraries, which are structured by assembly of complex objects. But there is one last feature of ActionNet which makes lean automation even more valuable. It's possible with the software extension functionality to export and import libraries. Thus, ActionNet users can share libraries with each other. As an example, we include these 2 images on the slide. On the left, we have a build project with components that can be selected, including all the elements it contains. Here on the right, we show the import process display. We are very excited about the potential of lean automation, and we would like to invite interested parties to contact us for more information and start using the methodology in partnership with us. Thank you for your attention, and see you next time.